Hello and Assalamualaikum. My name is Muhd.daniel alias. I'm from class DEM 4A, section 2. My registration number is 14 DEM 20F10118. My lecturer name is Puan Ainul Azniza binti Ahmad Zaini. Today I will present about electrical component that calls IGBT. Firstly, what is IGBT? The insulated gate bipolar transistor, also called an IGBT for short, is something of a cross between a conventional bipolar junction transistor (BJT) and a field effect transistor (MOSFET), making it ideal as a semiconductor switching device. The IGBT transistor takes the best parts of these two types of common transistors: the high input impedance and high switching speeds of a MOSFET with the low saturation voltage of a bipolar transistor, and combines them together to produce another type of transistor switching device that is capable of handling large collector emitter currents with virtually zero gate current drive. Next, explain and sketch the diagram for IGBT. This picture is a diagram for IGBT. IGBT can be constructed with the equivalent circuit that consists of two transistors and MOSFET, as the IGBT possesses the output of the below combination of the PNP transistor, NPN transistor, and MOSFET. IGBT combines the low saturation voltage of a transistor with the high input impedance and switching speed of a MOSFET. The outcome obtained from this combination delivers the output switching and conduction characteristics of a bipolar transistor, but the voltage is controlled like a MOSFET. Since IGBT is the combination of MOSFET and BJT, they are also called by different names. The different names of IGBT are insulated gate transistor (IGT), metal oxide insulated gate transistor (MOSFET), gain modulated field effect transistor (GaNFET), conductively modulated field effect transistor (COMFET). Next is describe the function for IGBT. I will describe the function based on this circuit. IGBT has three terminals attached to the three different metal layers. The metal layer of the gate terminal is insulated from the semiconductors by a layer silicon dioxide (SiO2). IGBT is constructed with four layers of semiconductor sandwiched together. The layer closer to the collector is the P plus substrate layer above, that is the N layer. Another P layer is kept closer to the emitter and inside P layer. We have the N plus layers. The junction between the P plus layer and N negative layer is called the junction J2, and the junction between N negative layer and the P layer is called the junction 1, J1. To understand the function of the IGBT, consider a voltage source Vg connected positively to the gate terminal with respect to the emitter. Consider other voltage source VCC connected across the emitter and the collector, where collector is kept positive with respect to the emitter. Due to the voltage source VCC, the junction J1 will be forward bias, whereas the junction J2 will be reverse bias. Since J2 is in reverse bias, there will not be any current flow inside the IGBT, which is from collector, which is from collector to emitter. Initially, consider that there is no voltage applied to the gate terminal. At this stage, the IGBT will be in a non-conductive state. Now, if we increase the applied gate voltage due to the capacitance effect on the SiO2 layer, the negative ions will get accumulated on the upper side of the layer and the positive ions will get accumulated on the lower side of the SiO2 layer. This will cause the insertion of negative charge carriers in the P region. Higher the applied voltage Vg, greater the insertion of negatively charged carriers. This will lead to a formation of the channel between the J2 function, which allows the flow of current from collector to emitter. The flow of current is represented as the current path in the picture. When the applied gate voltage Vg increases, the amount of current flow from the collector to the emitter also increases. Next is give 5 examples of IGBT application. Number 1 is it is used in SMPS, which is switched mode power supplies, to supply power to sensitive medical equipment and computers. Number 2 is it is used in UPS, which is uninterruptible power supply system. Number 3 is it is used in AC and DC motor drives, offering speed control. Number 4 is it is used in chopper and inverters. Number 5 is it is used in solar inverters. This is all from my presentation. Thank you.